Welcome to another 10-minute coffee break tutorial, or shall I say, learning session. Let's talk about SSIS data transformations. In SSIS, data transformations happen in three places. First, the data flow task or the component-based transformations. Second, the execute SQL task or the stored procedure-based transformations. Third is the script task or the code-based transformations. In this three-part tutorial, we will cover all transformation approaches, and at the end, we will compare them so you can decide which method best fits your needs. Today, we are focusing the component-based approach, so join me and let's start with the no-code transformations.
Let's assume we are assigned to an import project where we need to load CSV data into our sales order table. The requirements would be only rows with a region value that already exists in the region table should be inserted in the sales order table. Any row with a region that does not exist in the region table should be sent to the exception table. All distinct region values from the CSV that are not found in the region table must be added as new region records. Only CSV rows with an order ID that does not exist in the sales order table should be inserted. And lastly, any CSV row with an order ID that already exists must be excluded from the import and inserted into the exception table. Let's begin by adding a new package to our SSIS project and name the package to data transformations. Then let's add a data flow task where all our transformations will take place and add a flat file source. We will use the same CSV file from our previous session in the connection manager and leave all its properties set to their default values. Now let's add an OLEDB destination and point it to our database. We will select the sales order table as the target. You will notice a data type mismatch on the order date column. This is because the order date field of the sales order table is a date data type. To fix this, we will add a data conversion transformation and convert the CSV order date to DB date data type. Let's run the package to confirm if the file loads successfully. Now let's add a lookup transformation to check whether a region value exists and use the region table as the reference. However, the region table doesn't exist yet, so let's first create it and insert some initial data. Now that the region table is ready, let's go back to SSIS and configure the lookup. We will match the CSV's region column to the region table's description column. Ideally, lookup should match on a key column because it guarantees uniqueness and improves performance. But sometimes the source data only provides descriptive values, so matching on a non-key column becomes necessary. Mapping the region table's description column to the CSV's region column results in a data type mismatch. This is because the region table stores description as NCAR or Unicode data type, while the CSV provides region as DP-STR or non-Unicode data type. To fix this, we will add conversion of the CSV region column to DP-WSTR in the data conversion transformation. In the lookup, we will use full cache mode so SSIS loads the entire region table into memory for faster comparisons. We will also configure the lookup to redirect rows with no matches. Matching rows will go to the sales order table and non-matching rows will be inserted as new region records. Now, let's remove the existing data and rerun the package. You will notice that no rows were inserted into the sales order table. Instead, all region values were inserted as new records, even though the region table already contains matching values. The process did not throw an error, but the result is logically incorrect. The lookup failed because the values didn't match exactly. SSIS reads the CSV values exactly as they appear, while the region table's description column is defined as NCAR, which pads its values with trailing spaces. Because of these padded spaces, the strings never match even though they look identical. To fix this, we need to trim both sides of the comparison. We will add a derived column transformation before the lookup to trim the CSV region value. Then, in the lookup, we will switch from using the physical table to using SQL query where we can apply SQL's trim function to trim the region table's description column. We will also update the column mapping so that the trimmed CSV region maps to the trimmed region table's description. Now let's remove the previously inserted records and run the package again. This time, the sales order table receives the correct rows. Now let's add new CSV records with region values that don't exist in the region table. Let's clear the data and rerun the package again. New region records are inserted but duplicates appear. This happens because the region table allows duplicate description values. We could add a unique constraint, but let's assume we are not allowed to modify database objects. To prevent duplicates, we will add an aggregate transformation before the region destination and configure it with group by operation. This ensures that only distinct region values get inserted. Let's clear the data and run the package again. Now the region table contains only distinct values. To send CSV rows with non-existing regions to the exception table, we will use a multicast transformation. Multicast allows us to send the same row to multiple outputs. We will place the multicast between the lookup and the aggregate transformations. Then we will connect the lookup's no-match output to the multicast. Next, we will add a new OLED with destination pointing to the exception table. Let's clear the data and rerun the package. Everything seems to be working correctly. Now let's rerun the package without clearing data. You will notice multiple rows inserted into sales order table with the same order ID, which violates our requirements. To fix this, we will add another lookup, this time using the sales order table as the reference. We will match the CSV's order ID to the sales order table's order ID column. We will fix the data type mismatch by converting order ID to 4-byte signed integer or DTI4 data type in the data conversion transformation. In the lookup, we will send non-matching rows to the sales order destination and matching rows to the exception table. Let's remove the inserted data and rerun the package. The records are inserted correctly even across multiple runs. Now let's add invalid data to the CSV and rerun the package. As you can see, an error occurs during the order ID conversion. This is because converting a non-numeric value to a numeric type throws an error. We will move the order ID cast to a derived column because it returns null in failed conversions, unlike data conversion. Those nulls are needed for conditional logic. Let's run the package again. Now, an error appears on the order date conversion. We will apply the same approach to order date, quantity, and unit price using the correct data types for each. We will also add a derived column for product using the trim function. Let's run the package again. This time, the error shows up in the derived column component. This happens because every derived column transformation is currently configured with error output set to fail component. We will switch the error disposition to ignore failures so any failed type conversions automatically return null. Some input columns were replaced due to upstream changes, so we will remap the correct input columns in the destination. We still have a data type mismatch on the product column. The trim function silently converted the product to DTWSTR, a Unicode data type, but the sales order table expects barcar, which is a non-Unicode data type. We will add a data conversion transformation to convert product back to DTSTR data type. Let's run again. Errors appear in aggregate and destination components. A tricky aspect of SSIS debugging is that errors often surface in components that aren't the actual source of the problem, which can make troubleshooting unexpectedly complicated. Let's focus on the destination error. SSIS continues to flag the order ID column because the value violates the table's integrity constraints. The derived column converted our invalid order ID into null, but the sales order table requires a non-nullable order ID. Since SSIS attempts to insert null, the destination rejects the row. For now, we will update the CSV with a valid order ID and handle proper null processing later. Running the package again triggers a new error, this time on the unit price column. We will return to the destination component and map the correct input columns for both unit price and region. You will notice that region now throws a type mismatch error. To fix this, we will add a data conversion transformation to convert region from Unicode DTWSTR to non-Unicode DTSTR, then update the destination to use the newly converted region code. Let's run the package again. At this point, the package completes successfully. Let's take a look at the data that was inserted. You will see that the sales order table now contains null values in the columns where our CSV had invalid entries. The region table also received a blank region value. Now, let's assume the project has some new requirements added. Only sales order rows with valid values for order ID, order date, product, quantity, and unit price should be inserted. Any row containing a null or blank value in any of these fields must be redirected to the exception table. Additionally, the region table must not accept blank region values. To handle blank region values, we will add a conditional split transformation before the aggregate. We will add a condition, region not equal to blank, and name the output valid region. Valid region flows to the aggregate, the default output goes to the exception table. Let's run the package, but first, let's remove the previously inserted blank region. The blank region is now excluded. Next, we will add another conditional split between the two lookups to validate sales order data. We will name the output valid data and connect it to the next lookup. The default output goes to the exception table. Let's delete invalid rows from sales order and rerun the package. Some invalid rows still appear. The conditional split used the original CSV columns instead of the converted ones. We will update the condition to use the converted columns. Let's remove invalid rows and rerun the package. At this point, everything is functioning correctly. We are now ready to run the final test. We will reset the CSV file back to its original values, clear the destination tables, and then run the package to confirm that all transformations, conversions, and validations behave as expected. First test run successful. The correct rows were inserted. Next, we will add a few rows to the CSV with region values that don't exist in the region table. This will let us verify that the lookup transformation correctly identifies new regions and routes them to the no-match path. Second test run is successful. Duplicates sent to exception, new regions inserted correctly. Now we will perform our third test run. This time, we will intentionally add rows with invalid data to the CSV so we can verify that our conversions and redirection rules behave correctly with the data quality breaks. The third test run is successful. Invalid rows excluded. Region table contains distinct values. Now we will perform the fourth and final test run, this time adding new valid records to the CSV to confirm that the package handles clean data correctly. All validations, conversions, and lookups behave exactly as expected. The project is now fully complete and meets all of the defined requirements.
That wraps up part 1. Thanks for spending your coffee break with me and see you in part 2.